Hi Year 12, this is the first of 6 lessons for the topic of vectors. So a vector is a quantity that has both magnitude and direction. It's represented by an arrow that has a beginning point and an end point. Now the magnitude is the distance between those 2 points, or it's the size or length of the vector. And the direction is represented by an angle to the horizontal. A scalar has only magnitude, no direction. And examples of scalars include distance. So I could say we have a distance of 2 kilometers. And speed. I could say I'm going 35 kilometers per hour. You can see how there's no direction given there. Examples of vectors include displacement. And displacement is like distance, but it will have a direction. So I could say it's 2 kilometers in a northeasterly direction. Velocity is like speed, but again it has a direction. So I could say it's 35 kilometers an hour, and I could give a bearing, say 065 degrees true. Other examples of vectors include acceleration, force, and momentum. Now there's loads of ways that vectors are written, and there can be some conflicting notation. So you will see a letter with an arrow on top, a letter with a tilde underneath. This is the one I tend to use. A bolded letter, or we can give the endpoints with an arrow on top. Now we say AB is the displacement vector of B relative to A. We can also say that AB is the vector that starts at A and ends at B. The magnitude or length of the vector is notated by putting absolute value signs around the vector. And you can see that in these 4 cases. But this is another way to do it. This is how we do it in coordinate geometry. This means the distance from point A to point B. Now vectors can be drawn from any point, so they're often referred to as free vectors. And all of these vectors are equal because they have the same magnitude and the same direction. A negative vector will head in the opposite direction to a positive vector. So in this case here, A and negative A are parallel. They are equal in length but opposite in direction. And we could say that BA is the negative of AB. Now with vector operations, there are geometric operations and there are algebraic operations. So we're going to look firstly at geometric operations. We can add vectors together, subtract one vector from another, and multiply a vector by a scalar. So if we want to add vectors together, the sum of 2 vectors is the combined displacement of the 2 vectors. Now what does that mean? We're going to take our second vector and move it up, because remember vectors are free to move around. We're going to apply it from the end of the first vector, and then the combined displacement is this orange line. We go from the beginning of the first vector to the end of the second one. So this is the addition of those 2 vectors, u plus v. If we want to subtract a vector from another, we add its negative. So remember how to do the negative? We're going to take v and turn it around. So there's negative v. Now we're going to add those 2. So we want the combined displacement. We start from the beginning of u and go to the end of negative v. So there's u, take away v. And we can also recognize the subtraction of vectors when the 2 vectors start from the same point. And this is really useful for when we do geometric proof. So I don't often recommend memorizing stuff, but this is one thing that I would memorize. So rather than doing negative v and then moving it up here and then going from here up to the end, let's memorize this. The vector between these 2, so between u and v, if it points towards u, this is u minus v. If it points the other way, then it's v minus u. So whatever it points to goes first. Now, what I want you to do for homework is go and prove that. Okay, take v, turn it around and move it up here, and you will see that we get the same vector. And then memorize it. And our third operation is multiplication by a scalar. And this changes the magnitude of the vector, but it doesn't change the direction unless the scalar is negative or 0. So suppose we've got the vector A, then this is the vector 3a. And it's actually the same as A plus A plus A. Now a couple of definitions. The 0 vector is a vector of 0 length. And we have A plus 0 is equal to A, and A plus the negative of A is equal to 0. And a unit vector has a magnitude of 1, and we write A with a little arrow on top. Let's finish off with vector equations. We can write a vector equation for any diagram where the vectors form a closed shape. So for example, we could say R plus S plus T is equal to U. And then we can move them all around. So we could say R plus S is equal to U minus T, or R is equal to U minus T minus S. So here's a couple of examples to finish. What is the addition of the vector AB and the vector BC? So if we take a vector AB, it doesn't really matter what it looks like. And that's A and that's B. And then this is the vector BC. Then the addition of those two vectors is the vector AC. Can you see any pattern here? See how this end point matches this beginning point? All right, how about this one? What is the vector AB plus BC take away DC? I can see that we can do that part, but what about this? Well, DC is equal to negative CD. So this is the same as AB plus BC plus CD. So what's the answer? AD. Okay, that's it for this lesson. In our next lesson, we'll look at algebraic operations with vectors.